All right. I want to thank you all for being here. For those of you who are here in office, how many do they get for being here? Because we're in expansion cycle. 15 tickets for being here in person. First prize is a $300 RER gift card. Second is a take care of yourself. It's like a foot massage and some different. What did you guys get? I don't even know what it is. Like gels and stuff. Bath salts, essential oils, a gift card to True Food Kitchen for food. So that's the second prize. So if you're here, you get tickets. If you're not, there are other ways to get tickets, but showing up, there are perks. So with that being said, I ran an Audible, and we're going to be talking about screen time and how it affects your brain. So we're going to look at the different effects on everything from cortical function, neurodegeneration, dopamine function, and the brain waves themselves. So with that being said, my hope is that we get one or two takeaways from this, things that we can actually use at home, understand how the screen is actually affecting us, how our bodies are changing, and what it's actually doing for us. So any guesses? How long does the average American use their screens minus their job per day in hours?
Does this include like TV?
It includes TV, cell phone, GPS, anything besides your job. So we got 6 hours. Any other ideas? 8 hours? 10 hours? I'm not going to give you the answer till everybody tells me an idea. 4 hours. So you got any answers, sir? 4 hours. So we got a was it a 6, a 10, an 8, and 2 4s?
Did somebody say 12?
All right. So the answer is 7 to 9 hours a day is the average American. So let's take that into account when I start telling you what it actually does to your brain. The next thing that we have to be aware of for children, it is actually their primary sensory input for a lot of them. Now, this is really important because we need to understand how the brain develops, and that's what I'm going to go into, and how the screen makes the brain develop. So when we look at kids, their brain develops from the bottom to the top, back to front. So what does that mean? The first thing that develops in any child is the fight or flight response. Then the next thing that develops is the cerebellum. Now the cerebellum is really important. The next thing we're going to look at is like limbic emotional stuff. And then we look at cortex, prefrontal cortex, frontal cortex, all that stuff. So everybody is going to have that fight or flight response developing in the beginning that starts being triggered or primed in utero, in mama's tummy. So when baby's moving around in mama's tummy, that's actually the fight or flight response being triggered. So it's actually reflexes being triggered by the fluid, the amniotic fluid going over their face. So it goes over their face and it triggers them to move their arm or kick their foot. So the fluid is actually triggering it, but that trigger doesn't mean they're in protection mode per se. It's triggering their nerve system to actually wire correctly. So those reflexes, like one of the ones that we test on you called the atonic neck reflex, which is the one when you turn your neck, you go like this. And you'll pull this arm in, bend this leg, and push this leg out, and that arm out. Well, that reflex will actually trigger your brain to develop correctly. So if it's not developing correctly, then what will happen, there we go, perfect. So it'll trigger your brain to develop correctly, and it's specifically your special senses. So seeing, hearing, smelling, taste, touch, all that stuff.
Sorry, I was saying.
So when we look at that, we want to understand that the brain stem is first when turned on and helps you interpret the world. Then the next thing that's going to develop is the cerebellum. Now, any ideas what the cerebellum does? We can guess here.
Muscle control.
Muscle control. Anything else? If you don't know, it's okay. I'm going to teach you. All right. So it is muscle control, but it's also learning. It's going to be task-oriented learning, spatial-oriented learning. It's going to be keeping on tones and beats. It's going to also be stimulating the frontal lobe so you can keep focus. So if any of us notice that if we're really groggy in the morning, we don't know what to do, then we go for a walk, all of a sudden our brain turns on. That's because the cerebellum will trigger your frontal lobe to turn on. If you're really groggy and you don't have a laser and you don't have time to go for a walk, you can actually do cross-crawl patterning that will stimulate your cerebellum to turn on so you'll become awake. So that's like taking your hand to touch your ankle, your knee, your hip, and doing it on the opposite side. And if you do that for a minute, it will actually wake you up. And then if you want to get really hardcore, you can do backwards cross-crawling, and that will actually wake you up as well because your body isn't used to moving backwards. So it takes a lot of cortical function to wake you up. So when you do it, you don't want the same side moving backwards. That means that reflex, that ATNR reflex is stuck on. You want the opposite leg and arm going backwards. That will help you. You're not going to move. You're just going to move do exactly what I'm doing. Yeah. So you're going to go backwards, backwards, or forwards, forwards. And that will actually stimulate your cortex to turn on because you're making it a hard cerebellar movement. So brain develops bottom, cerebellum, midbrain, top. And the top is going to be all of that cortical function. The problem is when children are using the screens when they're little, they are not stimulating their cerebellum at all. Normal learning involves cerebellar function. So it's going right to frontal lobe to conceptually understand what's going on, as well as going to occipital cortex to visually recognize what's going on. So if you want to see if your child or your friend is stressed out because of something they're watching, this is something we do with my child. We literally touch her hand and see how sweaty or dry it is, or cold it is, I mean. And if it's sweaty and cold, we know she's stressed out by the television show she's watching. So that's letting us know that's not a good thing for her because her body physiologically is telling me she's stressed out. Now, you need to understand, though, that there's a reward system being in play here. So with the screen flickering quickly, swiping left or right quickly, you're getting easy dopamine rewards. Now, what does dopamine make you do? Do you guys have any ideas? Makes you feel good, but it also makes you finish tasks. So if you have low dopamine, you have a hard time finishing tasks. If you have low serotonin, you have a hard time starting tasks. That's why I hear people who are depressed, they have a hard time doing things, starting. But if they have low dopamine, they have a hard time finishing. So when you are an adult or somebody like that, or a child, and you're used to swipe, get a reward, change of the screen, or scroll up and change the screen, you are actually wiring your brain to learn that no effort is needed to get dopamine. That's a problem because low energy expect dopamine reward. That's not how the world works. If you want to produce something, you have to work hard to produce it. Well, you're wiring your brain to do the opposite. You're wiring your brain to be easily dopamine rewarded, and then that's going to lead to things like easy distractions because you can't focus because you're used to getting a reward. It's also going to lead to things where your ability to stick through hard tasks drops substantially. Now, what is this doing to your actual brain? When we are exposed to chronic screen time, MRI studies have shown it will actually shrink your cortex. So that means your gray matter gets smaller. You get neurodegeneration in both children and in adults. In children, what we'll see is the prefrontal cortex, the executive, the emotional, the memory, all the stuff that makes you you and makes you not do stupid stuff gets smaller. So that's a problem, because if we have a shrunken frontal cortex, we're going to be easily distracted. We're going to make unwise decisions. That's a big issue, because it's okay if it's one time, but now if we have millions of people that are easily manipulated, easily driven towards certain things, then they'll take anything anybody says and believe it to be true. So we have a population that can be easily manipulated, and that's scary for me. So what do we want to look at here? If the child is exposed, their brain is actually going to develop backwards. The frontal lobe will turn on, the motor cortex will turn on, and the brainstem will turn on, but they have no way to process stress through the motor aspect. Now, why this is important is because stress management comes down to multiple layers of how we deal with things. The optimal way to deal with it is visual. Now, that's prefrontal cortex. If it's that smaller in somebody, but they're trying to use it more, that means it's not a productive way to deal with stress. That's what the adults get after 25 years of age. Their prefrontal cortex is at optimal function. Then we're going to drop down into auditory. So that's talking to yourself and so forth. That's going to be temporal. Below that, the next processing task that helps you deal with stress is all cerebellum related. That's going to be fine motor, tongue, hand movement, and gross motor. So if you do not use motor development to learn how to deal with stress, that means as soon as the person gets stressed out enough where they drop, and I've seen this quite often, where they drop and they go, well, I'm stressed, so I can't think about it. So they see them start talking. Then they'll go from stress thinking, they can't figure out, talking, to anger. And they won't have two stages to actually deal with it. And that's where they'll fall apart. Now, the long-term effect of this is anger, but it's fight, flight, freeze. But when I say anger, it doesn't mean necessarily you get angry. It means your body goes into fight or flight. Now, when your body goes into fight or flight, that means you, if you stay there long enough, will turn on your epigenetic disease. So what does that mean? That means, what has your family learned to do for the last 14 generations? If your family learns to turn on autoimmune disease, that means you get stressed, you turn on autoimmune disease. If your body turns on stress response where your muscles start fatiguing, and if you have a cerebellar issue, you're going to start seeing a lot of people with back pain, neck pains, chronic pains, because they're not going to be able to actually stabilize themselves through movement. We were always taught when you're young, go for a run, it'll calm you down, go work. That's not going to work anymore, because that person is not going to be able to actually move to stabilize themselves, because their brain is not going to be stable there. One side effect that you're going to start seeing very common is you're going to see an increase in tinnitus and vertigo in young children. That means ringing in the ears, balance issues, visual issues. That's a weak cerebellum. So we're seeing kids who can't track things correctly, or they get nausea really easily in the car. That's all because the cerebellum isn't working correctly, and then their limbic, or their spatial awareness center, is not going to work correctly. So there's different ways we can test this, but understanding this tells you, okay, so you're telling me if I'm in front of a screen, it can literally lead to me getting vertigo? Yeah. If you're a young person. If you're an adult, it can happen as well, because you're sedentary and it's causing that neurodegeneration as well. And the thing that we need to understand is all of us are going to degenerate our brains. The speed at which we degenerate determines how healthy we are and how long we live. So the key is to keep as much energy in your brain as possible. That means mitochondrial content. The stronger it is, the better it is. What is the easiest way for me to stimulate your brain and upregulate function? The adjustment. What's the way that I can literally make you make more mitochondria in your brain? The laser. That's why we got the laser on board, is to actually upregulate mitochondrial growth in wherever we put it. Now, the cool thing is each time you use the laser, more mitochondria grow in that area. And you go, what does that mean? That means you make more energy in that area for the rest of your life. What we need to understand is what aging is. One of the major factors is over the age of 50, we lose 50%. That means half the energy producing cells in our body are gone after the age of 50. That's why it's harder to heal as you get older. So when you're 18, 17, 16, you're at peak energy production. You heard something, your body has enough energy, it literally sucks it up, heals it, everything's good. But after 50, unless you're cheating and doing things to, well, I don't know so about cheating, biohacking, let's put it another way, to actually make more mitochondria, it's harder. And that's why you don't heal as quickly. There are other ways that people do this, like cold water plunges or saunas and different things like that. But the easiest way that I found in the office, because I don't feel like putting in a sauna and then everybody has to sit in it for like half an hour or anything like that, is the laser. So we look at this and we go, okay, so you're telling me the screen literally shrinks my brain and changes how I perceive the world, how I get dopamine. Yes. That's scary. The results of this that lead to that neurodegeneration is 2 hours of screen time. 2 hours of screen time will lead to neurodegeneration. Now, I thought it was interesting because in the research, depending on who you look at, they say not counting work.
Why? How is that?
I think it's BS too.
Magically, my brain knows.
Exactly. I think it's BS too because it's literally, well, no, 2 hours affect a child this way, 2 hours affect an adult, but then you ask a journal article and it says, oh, but not excluding work because we don't want to mess with work. Yeah. No, it counts work. So you're seeing a lot of people are getting neurodegeneration just by what they do for a living, which is scary. So then we have to mitigate it. And the things that are going to mitigate it are movement, laser, chiropractic. These different things are going to literally push it up. They're going to help you be able to do better. And you're like, but doc, I'm stuck in a chair. I can't move. Okay, we got an answer for you. You get a vibration board. You put your feet on the vibration board. You stick the vibration board to 40 hertz, and it will literally do the same stimulation because your ankles are going to stimulate your brain and it's going to turn it on. And then if you do that long enough, you'll literally be able to then move and start moving. If you want to get a little more active and try to drive more oxygen into the brain, drive more mitochondrial density, and you can't use the laser, there are the blood flow restrictive devices that I've shown you before, where it actually restricts blood flow to extremities, and you exercise at 30% and will actually make growth hormone buildup, nitrous oxide release, and it will boost your ability for your body to make more mitochondria. So it means you slow down aging. So there are ways to do it. The cheapest, most cost-effective way is movement. Movement is the answer. Here's the issue. If you're a child, you got to get them outside, away from the television, doing things. If the child is clumsy, and you're seeing this, or you're finding yourself clumsy, that means your cerebellum's getting weak. Now, I didn't get to this yet, but your cerebellum also, in conjunction with your frontal cortex, down-regulates your emotional centers in your brain, your limbic, as well as your brainstem. So what we'll commonly see, and one of the tests that I do with you guys is the ATNR test. So I have it where I go like this, and you move your hands. And if we see it like this, it's telling me that you have that active reflex, which means your cerebellum and your frontal lobe are so weak, they're allowing that primitive reflex, that reflex from birth, to be stuck on. Now, how does this show up in children? If you see them running and they turn their head and then all of a sudden they fall over and they're clumsy and they trip, that means that reflex is active. If you notice yourself, you're like, everything was fine. I turned my head and then I just started falling down. That means it's active in you. Now, that reflex doesn't mean that you're a child. It means your brain is operating at that developmental state. What we see is as you age, those reflexes come back on because your frontal lobe gets weaker and you stop stimulating your cerebellum. So I'll see it. I've had 80, 90-year-old people come in here, and those reflexes that we see in 9-month-olds are active in 80 and 90-year-olds, and are active in 20 and 30 and 40 and 50-year-olds. We'll see them really become active when they are people with like head injuries or chronic substance use, because those things are neurodegenerative. So what we want to see is, how do we keep the brain healthy? And that's the big takeaway is, make the cerebellum healthy, make the frontal lobe healthy. What happens when you're stressed out? Where do we take blood from in our body? I'm just going to go with the brain. We actually take it away from the frontal cortex and move it to the brainstem. So if we're chronically stressed, and a way to tell this is, are your hands cold when you're watching television or playing on your phone? Are your hands sweaty? This is telling me you're stressed out. That means you're literally taking blood away from your frontal lobe and you're getting those dopamine hits. That's why doom scrolling is so addictive, is you're getting quick dopamine for free. You're like, what has happened? 2 hours went away. Yeah, you just got high off your phone. That's literally what's going on. It's not a joke. That's literally what's going on. And you're rewiring how easy things are. So what's that going to do? The gaming, the fast scrolling, the notifications. That's the one that was interesting to me, the notifications. So how many of you hear the bing and you're like, ooh, what's that? That means you're getting a dopamine hit from that bing, that noise. So if you want to help yourself, maybe we want to silence the notifications so that we just look at the phone and see, instead of every time we hear bing, 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 dopamine rush, dopamine rush, dopamine rush, what's going on? Oh, I need that. I need that. I literally had to do this because it was annoying me. I could feel myself getting it, and I'm like, I got to turn this off. Because if you do it long enough, you get used to it. And then your reward center just doesn't work. So what are we going to see if that dopamine is off in adults? They're going to be switching tasks very quickly. They can never take tasks to completion because they're used to new. Oh, well, I don't like this job anymore. I got to do a new job. Or I don't like this. It's too hard. It's too easy. Whatever. I got something new. They're never taking tasks to completion. And I'm seeing this more and more in younger client or younger staff that I have, is they get bored easily because they're stuck on it. So one of the questions we literally ask them, because phone addiction is real, are you willing to put your phone down during work hours? If not, this is not going to work for you. Turn it off, silence it. Because that dopamine hit and stuff, it will actually deplete it. And then you're going to feel more depression and anxiety, because specifically anxiety, because you're using it up all day instead of using it and getting the reward from actually doing things that are good for you, like going for a run or a walk, or, taking care of yourself. The other thing we'll talk about is blue light. So with the screen, you're going to get the blue light. Now, we've all heard blue light is bad, but we need to understand why. Do we have any ideas why blue light is bad? Do you know what it stimulates? Any ideas? No? It stimulates your sympathetic tone. What does that mean in simple response? Blue light from the screen turns you into stress. It literally turns on the stress response. So what does that do? That's going to lead to elevated cortisol, which is going to lead to increased inflammation because your blood sugars are going to go out of control, which can lead to neuroinflammation, which can lead to chronic pain. So you're telling me, Doc, watching Gilmore Girls, I don't know if we watch that anymore, whatever it is, that's literally causing my chronic pain? Yes. Or Ted Lasso, or whatever your addiction is, that's driving it because it's doing that. But what happens if you chronically push that sympathetic tone up? You stop metabolizing melatonin correctly to make serotonin, and then guess what happens? You can't fall asleep. So that's literally what the blue light does. It makes you not be able to make melatonin, serotonin. Now we can't sleep. So you're wired and tired.
That means if you fall asleep when you're watching TV, you don't have that problem.
The question is, does that mean if you fall asleep while watching TV, you don't have that problem? That's too single factorial. It doesn't, like, there's so many other things going on. You could fall asleep watching TV because you just ate a bag of Doritos and it messed with your neurotransmitters and gave you a blood sugar spike. You could fall asleep because you worked out too much that day. You could fall asleep because you're exhausted and you haven't slept. And like, it's not as simple as do you fall asleep with just that one thing? So I can't answer it that way. I'd have to literally go, well, what does your day look like that day? Walk me through all the things you do that day. And then we know if that is the issue or not. So we're not sleeping, low melatonin, all because of blue light. So what's a trick code that you can use? No screens. Oh, doc, that's not going to work for me. Okay. Then we can use blue blocker glasses. Well, I don't like them. Okay. Use orange or it's not red colored. It's actually orange glasses. You can use them and they'll calm you down as well because they're calming down the brain. So the blue is going to speed you up. The red or orange is going to calm you down. So what's the takeaway from this? What do we need to see is that if we're doing these things, we're actually rewiring how we experience pleasure. We're rewiring how we actually experience the world and how quickly we need stimulation. And this is the scary part. It's leading to sleep issues, neurodegeneration, specifically gray matter shrinking. That means you become stupid in simple terms. And it's keeping you stuck in stress. So why do we get addicted to it? We get dopamine rushes every time we do it. And when you get a stress response, this is the thing nobody talks about, you also get a dopamine and an epinephrine. You get an adrenaline push every time you have the stress response. So the TV is literally driving you, or the TikTok or Facebook is driving you with those pushes. And that's how they get you. The part I didn't get into, because we're done, but I'm going to go into it quickly, it also stimulates what's called theta. The brainwave produced when you watch television or screens is a slow brainwave that becomes addictive. So it slows down your brain so you can't process as quickly. And that's why when you take it away, the kid freaks out, besides the dopamine as well. But it makes you feel calm. But it's only giving you the calm feeling. As soon as you take it away, it's gone. And then you feel stressed out again.
And isn't theta the brainwave that doesn't discern or judge anything? It just lets it all in.
Correct. So theta is subconscious processing. You just let everything in. So that's scary because if you're in a theta brainwave state, you're literally absorbing everything that's coming in. You ever thought, why do infomercials still exist? Because they're literally programming you. You're in a light sleep state and you could fall asleep and they're telling you to buy stuff because it works. So that's scary. So that's some of the things that come away. So what do I recommend? Red glasses. No screens before bed if possible, an hour before bed. Try to limit screen time to a couple hours most. And get movement going on in your life. Walking, running. If you can't do that, put your feet on a vibe board. Make sure that your blood sugars are under control, because if you're not having them under control, you can actually be addicted to the television because it's going to spike your blood sugars to make you feel calm. With all of these will help you. And there are more, but these are the simple, easy ones. Do we have any questions?
The blue light glasses, some of them say blue light, but they're not actually tinted red or orange. Do those really work or no?
From what I've seen, yeah, the blue blockers will work, even if they're not orange. The orange is to actually, so there's difference between blue blockers and orange glasses. So the blue blockers will stop the light during the day. The orange will actually change your brain down and calm it down so you can actually sleep.
Is
So
that the ones they call amber that are?
Yeah.
driving
So that's like
blind and
the
stuff?
pink color, or what is it called? Seeing life through the rose-colored glasses. That rose is actually calming your brain down. So the blue blockers work during the day, and then if you want to be able to fall asleep, put them on an hour before bed, and then we'll calm you down. That answer your question?
Yeah.
Perfect. So if you have friends or family members and they need help with different things like this, we can also obviously help them. We are in our expansion cycle, like I was letting you guys know. Our Patient Appreciation Day is April 2nd. So that whole week before that, friends or family members can come in for that discounted rate. So I want to thank you all for being here. Think of a family member that you can help, and have a blessed night.